Well, thanks everyone for coming this afternoon. My name is Devesh Goyal, and I'm joined by my colleague Rama Chintapalli, and we're product engineers on the ArcGIS Runtime team. How many of you heard .NET developers? Couple. How many of you are Android developers? iOS? Qt? Java? How many of you are not developers? Looking at you, yeah. All right. Well, this is a session that's going to be focused on developers. We're going to show some code, but there's some high-level concepts that everybody can take away. So, how many of you built an app already with the runtime? Some of you. Do your apps work offline already? Yep. And how many of you are planning to build offline apps in the future? All right. Well, you're in the right session. So offline is important, as many of you know who've built offline apps already. And that's because GIS workflows are increasingly moving out of the office and out into the field. And that's where the GIS data is either captured by field workers or they need access to it so they can do the right thing. So in this transformation, we see that a lot of companies are moving away from paper-based workflows and moving into the digital age and using digital maps. As they make this transformation, it becomes increasingly hard that these digital solutions work in our analog world sometimes, where there is limited, slow, or no network connectivity. And it doesn't always have to be that you are in an exotic location, like at the top of a mountain or in the middle of a rainforest where you won't have network connectivity. Sometimes the users of your apps can be in the heart of the city, but they may be responding to a natural disaster where the infrastructure has been taken down, so there is no network connection. Or they may be working in basements where it's very hard to get a Wi-Fi or a cell coverage signal. And in many countries, the network connection is not very reliable. Even though it's present, it's high latency, low bandwidth connections. So all of that has an impact on your apps, and you have to take that into account. But no matter what the situation, your apps still need to work. And that's where having the ability to work offline greatly helps. So ArcGIS Runtime has a variety of capabilities that you can use in your native apps. And all of these capabilities are available to you whether you're online and connected to the network or you're offline without a network. I'm not going to go into the details of these capabilities, but in this session, what we'll do is give you an overview of how you can take advantage of some of the offline workflows to enable these capabilities. Now, the runtime comes in a number of different SDKs. We have an SDK for .NET developers, iOS, Android, Qt, and Java. But the capabilities are the same across all these SDKs. And even the programming patterns, practices, and concepts are the same. That's because we all build on a common native core. So you as developers don't have to relearn it when you move from one SDK to another, because many times you will be building on more than one platform. Also, we try very hard to make sure we give you the same APIs that will work online or offline. We don't believe we have to design a set of APIs that work when you're connected and then a completely different set of APIs when you're disconnected. We'd rather have one set of APIs that you can either pass a URL to a network service when you have a connection, or you pass in a path to a file on disk when you're offline. And then the rest of the API just works the same. So offline has been a key focus area for runtime since the very beginning. And over the course of the past many releases, we've continued to build on the offline capabilities in runtime. We've added support for more data types in the past few releases. Things like OGC geo packages, KML, shapefiles, many raster formats, vector tiles. But at the same time, we've also tried to simplify the API and give you more coarse-grained APIs that you can work with that do most of the heavy lifting for you and make things easier for you as a developer. But we don't want it to just be a developer story for app. We want offline to be pervasive across the platform. So we made it more platform-centric, where users can author maps and scenes and enable them for offline that can then seamlessly work in your runtime-based application. At the same time, we're trying to make it configurable so that users who have a variety of different needs can still use the platform to meet their specific situation. And added support for scripting a lot of these offline workflows and data provisioning workflows, added support for 3D, so on and so forth. And it'll continue. We're going to continue to focus on improving offline capabilities. So come talk to us after the session if there are things that you don't see or things that you would like, and we can try to work that in. Now, I thought it was important for me to mention that a lot of the capabilities that we build in runtime are first adopted by our own Esri apps. And this allows runtime to be really tested out in the real world condition. So a lot of our apps support offline workflows today. For instance, using Explorer, you can take maps offline and view them and query features. Using Navigator, you can navigate offline, find routes. Using Collector, you can take your maps offline, edit data, and synchronize changes with the service, and so on and so forth. Now, I would advise you to look at these apps first and see if these can be part of your workflow, because they've been built by us using the best patterns and practices and have a large amount of usage. So they may just fit your needs, and it's okay to rely on these apps. But if you want to build a custom app that works offline, be confident that runtime is going to work for your apps because it already powers these. Now, when you start building your application, we would encourage you to think about connectivity in the very early stages of your app design. It's not something that you can iterate on and bolt on at the end, because it is very fundamental. And we've seen this with our own apps. If we make the wrong decisions in the beginning, then we have to come back and redo a lot of things to accommodate offline patterns later on. And there might be 3 different ways your app works, right? Some apps may only work in the connected state. They require a network connection. And that may be because your users are always in an office or have access to reliable connection. And you can consider the case where they don't have a network as an error condition, and your app can stop functioning. And that's okay. On the other end of the spectrum, you may want your apps to work offline right from the get-go, where they never connect to the network. And this may be because of security reasons. For instance, devices are not allowed to connect to external networks. So here you have to figure out how you're going to provision the data on the device to make sure your apps can work right from the beginning. And then finally, we have a hybrid scenario where your apps may start off and have a connection to the network, but at some point during the course of the day, an event happens and there is no network connection, but your users can plan ahead and prepare for that event and go offline so that they can continue their work. And when they have a network connection again, they can send stuff back to the service or do what they want to do with online connections. So in the connected scenario, it's pretty simple. Your apps can access maps and scenes from the portal or access layers that are coming from services. Now, runtime does a lot of ambient caching, so the tiles we bring down to the device, we keep in memory or store them on disk temporarily, same with the features, so that if you temporarily lose connection, your map won't freeze up. You'll continue to be able to see the data that was already fetched over the network. But you won't be able to do things like edit data and push it back to the service or query for things that are not in your map. But that's really simple, and that's not the focus of this session. The other end of the spectrum is for fully disconnected workflows, you author your maps and scenes in such a way that they can be just side-loaded onto the device. And your apps have access to that, and that's what they work against. In the middle is what we have for the occasionally connected scenarios where the app starts off connected, and then the user chooses to go offline by taking map areas offline either on demand or through pre-planned workflows. And we'll talk more about those in a bit. And we sometimes refer to these occasionally connected workflows as the services pattern because you're extracting data from a service, or the desktop pattern because you're pre-packaging your data using our desktop tools. Now, there are a number of data formats that we support in runtime when we're offline. We can display vector and image tiles that are really good for base maps. We support features along with their attachments and maybe related records that may be spatial or non-spatial. We support feature collections, which is basically a blob of JSON that may be sitting on the portal or as part of the map. And we support 3D workflows using I3S or scene layer packages, so on and so forth. Now, depending on the pattern you use, if you're using the desktop pattern, you have access to all of these different data types. But if you're using the services pattern, you get access to only a subset because we only support extracting some of these data sets from the server. And today, we'll be mostly focusing on maps and scenes as a way to work offline. In the past, we've talked about working with layers offline that gave you more fine-grained control, but as a developer, you had to write a lot more code to make your apps work correctly. Maps and scenes are a central concept in ArcGIS. They nicely organize your layers. So if you can take a map offline easily, then we do all the heavy lifting of handling all the layers inside it. So let's talk about taking a map offline using the services pattern. The one thing that you have to do in this case is make sure your services are set up to go offline. So if you're using tile services, you need to check that box that allows offline mode. And if you're using feature services, there is a checkbox for enabling sync, which allows us to extract features from the feature service. You may or may not make your feature service editable. If you make it editable, then users can go offline and edit data. But if you don't, then they can only just pull changes from the server when they have a network connection. So in the services pattern, let's talk about the on-demand workflow first. In the on-demand workflow, you basically set up a map and you host it on either ArcGIS Online or on ArcGIS Enterprise. And it's got all the layers that you need in the map, and it's usually pointing to services. Your application accesses that map from the portal, and when it's ready to go offline, it sends some parameters over to the portal that ask the portal to package all of that data up. It extracts tiles from tile services and features from feature services, and then downloads all of that data onto the device. Once that data is on the device, the app is free to use it by displaying the map or edit it if editing was allowed, and then synchronize the changes. In this workflow, when you specify those parameters, you get a couple of options as a developer that are pretty basic. You can specify what area of interest you want, and typically you may want to ask the end user for that by allowing them to draw something on the screen. And also what scale levels do they want to take offline. That allows you to control the number of tiles that are taken offline. But you can also choose whether you want to take the base map offline or not. In many cases, you may already have a base map on the device, and you just want to take features offline. And for those features, you may decide you want attachments or not. So there's some high-level map parameters that apply to all the layers in the map. But if you wanted more control on a layer-by-layer basis, you could specify overrides for each of those layers as well. So to give us a demo on how this works, I'm going to pass it over to Rama, who's going to show us a iOS app.
Yep. Thanks, Devesh. Let's switch to 3. Okay. So here I have a web map which kind of used as a story for, say, for example, an arborist or engaged citizens who wants to perform inspections on the kind of condition of the trees in the city of Portland. So I have a web map here which has trees layer and neighborhood spatial layers, and it has some related tables which include the inspection data. So now, like, we want to take this web map offline and use it for offline workflows. So the first thing, as Devesh mentioned, was to check whether it is enabled for offline use or not. So for a web map to be enabled for offline use, you need to make sure first, like, you go to check your layers whether they have sync enabled or not for the feature services. So I go to the feature layer, which is being included as part of an operational layer in that web map, and I go to the settings of it. In the settings, you can see the option of enable sync. So this is the one, like, you need to turn it on in order for your web map to even kind of open the offline settings. So once you have that, and it also has a lot of other editing features like ownership-based access and things like that, which are specific to the feature services. So once you have this enabled, you can go to the web map and go to the web map settings. Only if you enable sync and the feature services, you can see that there is an option for offline settings for a web map. And if you click on the offline settings, you can see this little button. That's the one that enables your web map for offline use. So you need to enable that. And there are more advanced options as well on how you want to control and the feature and the attachment delivery, as well as like how you want to control like the offline base map, how you want to use, whether you want to download or the whole base map, or you want to use an base map which is already pre-packaged and already deployed onto the device. So you can enable all those settings here. So once you enable the web map for offline, then you can switch to, or like you can go to your app and download it. So for that, I'm going to use an iOS app. So here is an iOS data collection app that I'm going to open, which is going to use the same web map that we authored there, which is enabled for offline workflows. So I'll zoom to a specific area. And then, so I want to take this map offline. So I go there, click on work offline. I choose an extent which I want to download. And then basically I try to take the map offline. So as it is downloading, let's see the code which is actually taking the map offline. So you just instantiate the offline map task with the map that you want to work with, and use the offline map parameters. So in this case, what I did was I'm actually making it to use an reference base map which is already deployed onto the device. Like if you go to the iTunes, you can see that this app has some local data installed, which is my Portland vector tile package. And that's what I'm telling the parameters to use the reference base map. And then all you need to do is call the generate offline map job and pass in the parameters, and also specify the download directory where you want to have the downloaded map. What it does is it packages the map and all the operational layers into a kind of a mobile map package, and then it stores on the disk. Depending on your network, it can probably take time, and you can see that the map is taken offline. And one thing you would have noticed that although we chose an extent, and the base map is this is bigger than the extent that we downloaded for the feature service. That's because we had a reference base map which we already preloaded. So I had a base map for Portland area, the whole of the Portland area. So that's why like you see the data is only on the extent that I chose, but the base map itself is much larger. So we have taken our map offline. This is in an on-demand workflow with a reference-based map. So with that, I'll give it back to Devesh.
Can you get 4? Yeah. Yeah, so just want to reiterate that point that was on demand. That meant that the app could specify any setting on basically what extent, what layers, whether attachments, base maps. And so that data needed to be generated on the fly. And because it needed to be generated on the fly, because of that customizability, it takes a bit of time. And if you have thousands of users doing that, your GIS server is going to get bogged down trying to build custom maps to take offline for all of your users. But again, just to recap, the workflow for developers is use the offline map task, generate some parameters. By default, these parameters represent the settings that the map author specified while authoring their map. If the developer wants, or the end user wants, they can override these settings in the app, and then you generate an offline map job that you send off to the server, and it gets you your data. So the next thing we want to talk about in taking maps offline is another workflow that we call pre-planned. And in the pre-planned workflow, the map author is in the driving seat. He decides or she decides how the map goes offline, what layers it includes, what areas, whether it has attachments, and all of that. And then the app just basically downloads that area. So because it greatly reduces the amount of customizability with these settings, it's much faster. And also, the map author can pre-generate these map areas before the app's ever even deployed onto a user's device. So for instance, here there's an area that has been created. You can go ahead and package this up ahead of time, and it'll pull the base map or the features and make it ready for the user to download. So if we look at the workflow for the pre-planned map areas, again, the author creates the map and designates certain map areas. Now, obviously, this only works well if you can predict in advance of what are the areas your workers are going to work in. And many times that's possible because you may be building an app for your sales force, and salespeople work in only certain zones. So you can then carve out your map into these different zones and pre-package them. Or utility workers may only be working in certain service regions. But anyways, you author your maps and your map areas, you pre-generate the data for all those map areas, and then when the app needs to go offline, it basically picks an area, downloads all the packages that have been pre-generated, and it's done. And then it can go ahead and use that data offline, maybe edit it and synchronize it back. So let's take a look at a demo that shows us how you can use pre-planned map areas to go offline.
All right, when I showed the settings for offline use of this web map, I intentionally avoided the map area section. So that's what we're going to use for the pre-planned areas. So in order to create these pre-planned areas, you can select this manage areas option, and you can see there are a couple of pre-planned map areas already created. So, but if you want to create a new area, you can select and give it a name, and then you can draw or create a new map area. And you can specify the level of detail that you want to include in packaging this. And then save it. So you can see that this one is right now packaging it. So behind the scenes, the service is actually gonna take that extent and it's gonna package it. Once it is available, it will be like the other two areas. So let's see how we can use it in an application. So for that, I'm going to use a .NET application. So here is an application where I sign into the portal, and I'm seeing only the web maps which are available for offline use, and I see I'm going to use the same Portland tree survey web map that we used for on-demand workflow. So I have this, and I go to the pre-planned section. So now I want to first get like what are the pre-planned areas that are already created for this particular web map. So I can query that, and I see that all the 3 map areas are available now. So I can choose one of them for download. So I'm going to choose one of them and download that particular area. So you can see that the pre-planned workflow is much faster than the on-demand one. Because it's already pre-packaged. All it's doing is just downloading one single pre-packaged file, which would contain everything. So the code for, like you saw, it's much faster. And the code for it is again, we will use the same offline map task. We're going to pass the web map, and for querying the pre-planned areas, once the offline map task is loaded, you just get the pre-planned map areas and use the pre-planned map area for downloading it. So, and you would call the download pre-planned offline map method and pass the selected map area that we have selected in the application. That's it. So that would download the pre-planned map area for you. And then you can continue to like work with it or make or sync the changes or whatever you want to do with that particular offline map. That's the pre-planned workflow. So back to you, Dipesh.
Get number 4. So we've seen that with the pre-planned workflow, it's really fast to take map areas offline because the data is already prepped ahead in advance. Of course, this means as a developer, you can't change what data to take offline. It is cooked the way the author decided to package the map area, and the app cannot change that. The other thing that's worth mentioning with the pre-planned area is right now, it's only really fast to go offline, but if the user makes changes to that area and edits the data and then tries to synchronize the data back with the service, it's still expensive because each user is going to be synchronizing independently, and if you have 10,000 users, they're all going to be hitting your GIS server on the back end, and things could easily become a bottleneck. In the future, in the next version of Runtime, we're adding support for pre-planned map areas with scheduled updates, where when things change on the back end, you can take the changes and stage those with the map area, so that no matter if you have thousands of field workers, they just pull the updates straight from the map area and they don't have to synchronize independently with the service. It basically boils down to then basically one sync call to update the map area, and all your field workers can piggyback off of that. So just to recap what Ramas talked about with pre-planned map workflow, same thing, you use the offline map task that you used in the on-demand case. But this time, instead of specifying parameters, you pass in the map area you want, and you get a job that will download it for you on disk. So up till now, everything we've talked about was getting the map or downloading the map to disk. The next thing that we want to talk about is something that people want to do most often after taking their maps offline, which is to synchronize and edit them. So that they can get changes from the server or push their changes up to the server. So basically, you take the data offline using either the on-demand or pre-planned workflows. You edit the data locally, and then You synchronize it by pushing your changes up to the service and pulling down any changes on the service that other users may have pushed up. And when you synchronize, you, as an app developer, and your app has control over which direction you can synchronize on. It can be bi-directional, in which case you're both sending your changes up and getting changes from other people, or you may only upload your edits and not get any changes from any other user. Or you may not even have editable data locally, and you just want to get changes from the server that other people have been making to it. So at this point, we just want to peel back the covers a little bit and talk about how sync actually works, because it is quite involved and it is an expensive operation. So basically, when you take data offline, any featured layers that you have, what happens is the feature services generate a mobile geodatabase that uses the SQLite format and puts all the features in it and sends it off to the client. This mobile geodatabase is enabled for sync. Basically, what it's got is some change tracking information inside it, so that when you make edits or add or delete features, it knows the changes that you've made. Now, when your application calls sync, runtime goes into that databases and pulls all of those changes out and generates a small change set, or a delta geodatabase, as we call it. It then uploads this delta geodatabase back to the feature service, telling the service, these are the changes that the client made on the device. The feature service then incorporates those changes into its database, but at the same time, if you were doing a bi-directional sync, the feature service would generate a delta geodatabase and send back changes that were made on the service to the client. Runtime would take those changes and apply it to the local data, and now both the server and the client are in sync again. They both have applied each other's changes. So it's a multi-step process, and it requires obviously a network connection to be able to go back to the feature service. But anything can go wrong during this multi-stage process. So there's a lot of resiliency that's built into this system, so that if anything goes wrong, the client and server are always in a known state. So let's say you were able to upload your changes to the server, but there was a network connection before you can download any changes back from the server. So the client thinks, boy, I don't know if my changes made it back in. If you call sync again and the client sends its changes to the server knows that it applied those the last time, so it'll just ignore them but send the new changes back to the client. So there's a lot of handshaking and acknowledgement that goes on in this whole process to make sure things don't get duplicated or lost. And synchronizing the map is really easy. We provide an offline map sync task that basically looks at all the feature layers in your map and calls sync for them and handles the multiple geodatabases that might be in your map. If you wanted more control over ability to sync each layer independently, then we provide a more fine-grained geodatabase sync task that you can use. But the map sync task is much more convenient, and we recommend you use that wherever possible. So with that, I'm going to hand it back to Rama to give us a demo of how editing and sync works.
So we are back to our data collector iOS app. So we have downloaded a particular on-demand area before. So we're going to make some edits to it. You can see that now we are working offline. So I'm going to identify a particular tree. So you can see the address of it and all the attributes of it and the condition of that particular tree. And you can see the related data as well, inspection. So I'm going to make a new inspection, and I'll say it's collected by Rama, I'll just put some demo as the notes and collected date that I choose. And I'm going to update its condition. Maybe it is not as good as it was before, so I'll update that. So I added an inspection record to it. So you can see a new record has been added. You will see the condition of it is changed, so the symbol of that particular feature is also changed. So now I want to make this change. Then I can go forward and make more inspections to multiple trees, and then finally at the end of the day I can go and synchronize that particular app. So the synchronization, as Devesh mentioned, will call the sync geodatabase method. It would create the delta changes that we made and push them to the service. And in meanwhile, if there are any changes made on the service by a third party, then those changes would be pulled back, and then both client and server would sync each other, and they would remain in a good state. So this one had a successful sync. So that feature should be available on the web map as well, the update. So that's the editing. Actually, there are multiple features in this particular app, like you can add attachments to your inspections and things like that, which probably we didn't go through, but the focus of this demonstration is to show how the sync works. With that, back to you, Devesh.
All right, thanks, Rama. So that was all about taking data offline in a services pattern, editing it, and then synchronizing changes back with the service. Now we want to move to the next section, which is using maps and scenes when you're fully disconnected, so using the desktop pattern. And in this pattern, basically, you use mobile map packages and mobile scene packages to contain your 2D maps and 3D scenes. And these can be authored using ArcGIS Pro. You can use a variety of different data types in these packages, including things like locators that you can use to find addresses and places, and network data sets that you can use to perform routing offline. Now, once you package all your data up using Pro, you have to figure out how you're going to deploy this to the device without a network connection. And many times you can sideload this data using either an SD card or an external USB drive, or sometimes you may even want to bundle it with your app. So when people install your app, it comes with the data that it needs. What's important to mention with this workflow is that it's a read-only workflow, that you cannot edit the data inside the package. You can only display it and perform things like finding addresses or routes. And if you do decide to use this pattern, then what we would recommend is that you check out the Street Map Premium for ArcGIS product. That provides data for a variety of different areas, including North America, Europe, Middle East, Asia, and provides really good base maps for all of those areas, including addresses and routes. And that is the data that is used by the Navigator app for all of its workflows. But they're available for you as well in pre-canned areas that you can download and use with your app. I'm going to go ahead and turn it back to Rama, who's going to show us a demo of how to create these map packages and then use them in a runtime app.
Okay. All right, so I'll switch to ArcGIS Pro. So I have, for this demo, I'm going to use the data for a Naperville water district. This is some sample data. In this particular project in ArcGIS Pro has multiple maps, 3 maps, one 811 map, which which includes the water lines details and water main details. Basically for people who make 811 requests about an leak or something like that. So this particular map is for those field workers to know where the problems are. And then there is an emergency response map, which is kind of symbolized based on the system valve types and the water main diameters. So this is more to know kind of whether there are any leaks or not, if in case of an emergency, so where to go, and the field worker would know that using this map. And there is also an capital improvement project map, which kind of shows what are the new water lines that are coming in that area. So it is symbolized based on the current and proposed water lines. So I have all this data which I want to give it to the field worker who is going to work completely offline. So I want to package all these into one offline content, which in our case is a mobile map package. So I want to create a mobile map package with this data. For that, I can look for the tools, geoprocessing tools, and look for create mobile map package tool. So you can see this particular geoprocessing tool has a set of parameters that it can take. So I can include all the maps that I want to be included. And I can specify an output folder and give it a name. So you can choose an locator. So in this case, I'm choosing an Upper Valley locator. Otherwise, you can always browse or choose any other locator that you have. Just point to an LOC file. You can specify an area of interest. Or you can do like clip features that you want, give a title, summary, description, like all those tags. And also, like you can see, there is an option to enable map expiration. So if you choose that, like you can see there are some additional options where you can specify the type of expiration, whether warn user when this map has expired, but allow them to use the map, or you want to completely block using that a mobile map package after a certain time. So you can choose that, and you can give an expiration date to that mobile map package and an additional message what you want to let the client know. So you can choose all these options and run the geoprocessing tool that would package all the data for you. So I already have a pre-packaged mobile map package, which I'm going to sideload onto my Android tablet and show how it works on runtime. So I'm going to switch back to the Android emulator here. You can see the mobile map package is on the SD card of this emulator, and this app is actually using that. So you can open the maps that are authored in ArcGIS Pro. It maintains the exact styling and the symbols, symbol models that are used in ArcGIS Pro. You can see that all the layers are available the same way that are authored in ArcGIS Pro. You can see that you can search the locator that was included as part of this mobile map package. You can search by address, or you can also search by a water main ID. You can click and see that information as well. And you can work with any number of maps that you include as part of your mobile map package. You can see in this case the capital improvement map, where you can go to a specific bookmark, see all the proposed lines that were mentioned. So it makes the field worker's job really easy, and he's working completely offline. And again, like as I said, you can work with any number of maps within this mobile map package. That's all I had for the mobile map package, and probably I have a demo for mobile scene package as well. Just like the way you created a mobile map package, we have a tool for mobile scene package as well in ArcGIS Pro. But I'm not going to author one now, but I'll show you how to render a mobile scene package in runtime. I'll use an iOS sample for that. Can go to the scenes. This is something that we started supporting from 100.5. So you can see this is a pre-authored mobile scene package of probably some buildings in Philadelphia. And you can see it renders very smoothly, and you get all the touch controls on this scene with great detail. Yeah, so basically the scene package and mobile map package, they follow a spec, and then they have the maps and layers and all the other additional information that is required for that. And it should work, the same data should work, are interoperable with ArcGIS Pro or any other product within Esri. That's it.
Cool. Thanks. All right, so we've seen a number of demos today, and you may be wondering how you could get your hands on some of these apps that we've been using for demo. And the good news is that we've been using what we call open source apps that we try and build to show how runtime can be used and what capabilities the platform provides. So if you go to developers.arcgis.com and just search for open source, you'll come to this page where you can see all the different open source apps we support. The first app that Rama showed on iOS was the data collection app that allows you to take map areas offline on demand, edit them, and synchronize the data back to the service. And then the other app that he showed was, and we have an Android version of the data collection app being worked on. There's one already available for .NET also. But the other one that he just showed right now was the offline map book for Android, which allows you to work with mobile map packages and use locators inside them. And we have the same one available for both iOS and WPF. So if you were to click on one of these things, we go into great lengths of explaining what is the data that we're using, how we set up that data, what are the APIs that we're using in runtime to build these apps, and then the architecture of the app, and then you can also go to the GitHub repo where you can download it and you can run it as is, or you can customize it and change it to fit your needs. We built it so that it could jumpstart your app development. So check out those open source apps. Back to the slides. In summary, we saw that there were two workflows for taking maps offline in an occasionally connected manner using the services pattern. The pre-planned workflow is something we introduced recently, late last year, and it's complementing the offline story along with the on-demand pattern that we've had since the beginning. I think we tried to show that if you adopt the WebGIS patterns of using maps and scenes, things become a lot easier for you as a developer, and you can use other tools in Esri to author your maps and scenes for offline usage. And then don't remember, you should take into account connectivity as a core requirement early on in your application development lifecycle so that you can build the right app. Like I mentioned, the offline capabilities have just been evolving in runtime over the last number of releases. In the next release that we're expecting in August, we hope to introduce pre-planned map areas with scheduled updates. That should make it easier for you to push out updates to thousands of field workers for some of those map areas. We'll support annotations and taking them offline in an on-demand pattern from feature services, and supporting group layer and mobile map packages. But then beyond, we want to support connected layers in offline map. So when you take a map offline, there might be some layers that you can't take the data offline for because that data is just inherently dynamic, like traffic data or weather data, and you want to use the latest. So having the ability to mix and match connected and offline layers in a map. And then supporting utility networks offline and doing tracing and things like that. So that's all the information we had for you today. I will encourage you to take our survey on the Events app. Let us know how we did and how you liked the session and what we could improve on. We take your feedback very seriously, and we try to make sure we give you the information that you really need. But that's it. We got a little bit of time left, so what we'll do is we'll wait for applause and then take your questions.